Buoyancy force is an upward force exerted on an object submerged in a fluid such as water, air, or any other liquid or gas. This force occurs because the pressure of the fluid increases with depth, creating a net upward push on the object. Key principles of buoyancy force. Archimedes' principle. Archimedes, a Greek mathematician, discovered that the buoyant force on an object is equal to the weight of the fluid it displaces. This means if an object displaces 5 kilograms of water, the buoyant force is equivalent to the weight of 5 kilograms of water. Cause of buoyant force: the pressure in a fluid increases with depth. When an object is submerged, the pressure at the bottom of the object is higher than the pressure at the top. This pressure difference creates the upward buoyant force, conditions for floating or sinking. If the buoyant force is greater than the object's weight, the object will float. If the buoyant force is less than the object's weight, the object will sink. If the buoyant force equals the object's weight, the object remains neutrally buoyant. For example, it will neither rise nor sink. Formula for buoyant force: the buoyant force can be calculated using F B equals rho F V D G F B equals rho F V D G, where FB buoyant force in newtons and rho F density of the fluid in kilograms per cubic meter, kilogram per cubic meter. V D volume of the displaced fluid in cubic meters, mg. G acceleration due to gravity, 9.8 meters per second. Everyday examples of buoyancy. Ships. A ship floats because its overall density, including air inside, is less than the water it displaces. Hot air balloons. They rise because hot air inside is less dense than the cooler air outside. Swimming. Your body floats more easily in salt water because it is denser than fresh water.